This is the watch section of a large electronics store in Tokyo. Lined up in the showcases are these Japanese radio-controlled watches. From bold, large designs to slim and elegant models, there's a wide selection from Japanese makers. These radio-controlled watches are used all around the world. Our story begins in 1989. Japan had experienced an unprecedented time of economic prosperity. Many people were purchasing luxury European watches at the time. Even though prices started at several $1,000s, the watches were in demand. A certain major watch manufacturer based in Tokyo was feeling the threat of competition. How could they distinguish themselves from the luxury European brands? The company decided it would compete on a technical level. A new project was started to develop a watch that would lean into their strengths in precision engineering. One of the people selected to join the project was engineer Yasuoka Tadashi. Here's how he remembers the beginning.
Swiss-made watches were at a peak. We thought that instead of going along with the luxury route, we would instead create a high-functioning watch that many people would want to use.
What new watch should they develop? At the time, there happened to be a kind of watch that presented significant technical challenges. The radio-controlled watch. Radio control refers to the ability to receive a radio signal carrying accurate time information and then automatically adjust the watch accordingly. That's how the watch keeps time with extreme precision. It was over in Germany that a watch manufacturer had just created the world's first radio-controlled watch.
We wanted to raise the bar for watches by improving the technology. We'd searched for so long to find something we could improve. When we hit upon radio control, we knew there was an opportunity for making something new.
The company would use their expertise to come up with a new Japanese design for a radio-controlled watch. And so began the new development project. Yasuoka was eager to get things rolling. When designing a radio-controlled watch, the key issue is to find a way to build the antenna into the watch. Yasuoka wasted no time in gathering materials for the antenna and commenced prototyping.
How should the wire be wound, or what type of antenna should we make? That's what was going through my mind. It really felt like I was starting from zero by myself.
Yasuoka toiled day in and day out to come up with his own design for the antenna. What he came up with was this 3-centimeter long antenna. But just as he was about to celebrate his success, he ran up against another critical design problem. And that was the cover for the watch casing. A standard metal cover would block any signal from reaching the antenna.
A common issue with antennas is that if they come into contact with something metal, that object becomes charged, greatly affecting the performance of the antenna. Most components inside a watch are metal, so it really seemed hopeless.
And so, the first completed model had the antenna right in the center of the face of the watch. The watch was sold in Japan for around $900 at the time, but it had a bold and unusual appearance. Yasuoka wondered at the very least whether it would be possible to move the antenna off the watch face. His attention turned to the sides of the watch case.
It's harder to read the time when the antenna is in the middle of the clock face. But there was really only the top or the sides to place it. If placed horizontally on top, the length of the antenna meant it would stick out in a funny way. So we had to go with the sides and make the most of the available length there.
This led to the second model, which sold for about $450. The antenna was placed to the left of the watch. While the watch face was clear of obstructions now, it still didn't quite look like a regular watch. Sometime later, a new engineer joined development of the radio-controlled watches. Takada Akinari. He'd been at the company for 2 years before he took over for Yasuoka.
The first step was to understand the development of radio-controlled watches in general. We knew that people weren't totally receptive to designs with an external antenna. It wasn't a good trajectory to be on, so I was honestly a bit worried.
Takada's goal was to go back to the standard round case design. That would require the antenna to be even smaller than before. How much further could they go? Takada reduced the size millimeters at a time, testing to see if it could still receive a signal.
The bigger an antenna is, the better it is at getting a signal. The key was to see how small the antenna could be while still maintaining good reception.
After a year of trial and error, Takada was able to make a 1 centimeter long antenna, less than half the previous length. This small antenna would be installed inside the case. The antenna had been shrunk, but the final problem was whether the antenna could still receive the signal behind the metal cover of the watch case.
We wanted to use a metal cover, but when we put one on, the antenna lost about 90% of its effectiveness. It really seemed like metal was completely out of the question.
Takada's idea was to use a different material for the cover. He carefully researched materials which would not block out the radio waves. These were the result of his efforts. At first glance, it appears to be a normal watch. But if you give it a tap, similar to dishware, you'll hear the familiar clinking of ceramic. And for this model, a black plastic cover was used on the back. But soon after the new models were announced, the sales department raised their concern at a company meeting. Was it really impossible to use a metal cover?
Watches are considered fashion accessories to some people. The plastic cover wouldn't match that level of expectations for those people. There was a growing opinion inside the company that the case had to be fully metal.
But putting the antenna in the metal case made it hard to receive a signal. The only solution was to increase the sensitivity of the antenna until it still received, even when surrounded with metal. In order to test this, Takada headed for the company's shielded room. This special room blocked out electromagnetic interference. Here, he would transmit the test signal and adjust the antenna until it could receive a signal inside the metal case. But the seasons turned to summer. Takada continued to work in the cramped room with no windows.
I worked on this over the company's summer holidays. The ventilation system had been turned off, and the shielded room was only about 3.5 square meters. It got to around 40 degrees Celsius in that room.
The result of this grueling trial? Takada succeeded in increasing the sensitivity of the antenna. A new prototype with a metal cover was prepared. The completed prototype was to be tested not in the shielded room, but outside in real-world conditions. Employees headed to locations across Japan for the final test. Takada's destination was here. Okinawa, the island about 1,500 kilometers southwest of Tokyo. Here, he would be able to test whether the signal could still be received after crossing the sea.
The tests done inside the shielded room were only to receive a mock signal. For a real commercial product, we needed to check multiple sample units at the same time to make sure they all worked properly.
Takada got straight to business. It was just a little past 2 p.m. If the signal was successfully received here, the hands on the sample units should automatically adjust themselves. Takada set up the box of sample units he brought from Tokyo. It was showtime. Takada stared intently at the clock faces. But the watches were all still showing the different times he'd set them to. They weren't adjusting.
The watches weren't receiving. I'd brought a simple device with me to check whether the radio waves here were strong enough. Based off that, there was definitely enough signal, but the clocks didn't appear to be receiving. I felt the color drain from my face. I had no idea what was going wrong.
With nothing left to do but hope, Takada maintained an unwavering gaze. And then it happened. The hands of the watches began to move before stopping at a precise location. Takada looked down to his wrist. It was displaying the same time as the model. It had worked. The test was a success.
I was overjoyed, over the moon. It can actually take up to 15 minutes or so after you start receiving the signal before you see a result. So the moment the clocks adjusted to the right time, I was elated. Such a relief.
That was how the first full metal case radio-controlled watch came to be released in 2003. The release created a new market space for watches, prompting other companies to follow suit with their own takes on the design.